Hello. Uh, Hello, this is Farhan Shakil from the Republic 2.0, and today we are going to talk about the superposition of waves from the chapter number 3 of Edexcel AS Physics. And this topic is included in Unit 2. And today we are going to talk about the stationary waves. So first of all, we need to understand what do we mean by the superposition of waves. So whenever we are talking about the superposition of waves, it is a phenomenon. Whenever you're talking about the superposition of waves, it is a phenomenon by which two waves overlap each other. And whenever these two waves overlap each other, they end up either getting their amplitudes added up or getting their amplitudes subtracted, right? So that is what you talk about the superposition of waves. And now there are different phenomenons resulting in the superposition of waves. One of them is the stationary waves, and the other one, secondly, we've got the interference of waves. We need to know the necessary conditions for the interference or the production of stationary waves. So remember that whenever you're talking about the stationary waves, two waves having the same frequency but traveling in the opposite direction create stationary waves. Any two waves having same frequency but traveling in the opposite direction. If they are traveling in the opposite direction, they are producing the stationary waves. Secondly, whenever you're talking about the interference of waves, we need to remember that whenever two waves having same frequency, plus if they are traveling in the same direction, if they are traveling in the same direction, is known as interference of waves. And firstly, we've got the stationary wave. Now, in this video, we'll be talking about in detail about the stationary waves and how stationary waves are created, right? Stationary waves, or some may know it as a standing wave. So we have got the stationary wave, or on the other hand, we can also call it a standing wave. Now, what is the difference between a stationary wave and the interference of wave? We've already talked about that. The phenomenon, whenever we're talking about it, the phenomenon by which two waves having same frequency, two waves having same frequency, but traveling in the opposite direction, but they are traveling in the opposite direction. And if they are traveling in the opposite direction, they would give rise to the stationary waves. For example, if I'm talking about an example of the standing wave, for example, I've got a string that is plucked on two sides, and I'm just, plucking this string from the very center. If I'm plucking this string from the very center, a part of the string must move upwards, and the part of the string must move downwards. Now, this part must be moving downwards, and this part must be moving upwards. Since we produced them with a single frequency, now they would be traveling in the opposite direction like this. And whenever they're going to overlap, they would give rise to the stationary wave. So that is how the stationary waves should be created, right? And now the important thing is, how would you get the expressions for the wavelengths and the frequencies depending upon their lengths? Now, for example, you can produce stationary wave like this, or the second scenario for the production of stationary wave, the stationary wave can be produced like this. You have got a single string, but now you're plucking in from two different ends. So you would be having a wave that got two loops, and it would look like this. Now, for example, the length of the string is supposed to be L. Similarly, the length of this string is supposed to be L as well. Now, how would you write that length in terms of wavelength, right? You have got this knot and you have got this knot as well. And we need to remember that the distance between two consecutive nodes is lambda by 2. So this length should be lambda by 2, right? So the wavelength comes out to be 2L, right? So whenever you're given with the length of such a system, you can easily determine the wavelength. And similarly for two loops, you can see that length has to be nod lambda by 2, nod lambda by 2. So the total distance in this case has to be just lambda. So wavelength comes out to be just L. Now, if you want to get their frequencies, for example, this was lambda 1 and this was lambda 2. And now if you need the frequency of such a system is going to be V upon lambda 1, and lambda 1 is 2L. And the frequency of such a system would be equals to V upon L, because lambda 2 is L. So that is how, depending upon the given schematic representation or the given phenomenon, we can evaluate the formulas for the wavelength and frequency. And these are the formulas that we're going to use in any question that comes up with the stationary waves. Thank you very much. This video was just on the stationary wave. In the next video, I'll come back to you guys with the interference of light.